This is Margaret Lee, Special People and Places. Today I'm on campus at the University of Alabama, Galilee Hall, and I am with one of our favorite professors, Dr. Ron Buda. We came down to videotape his lecture, his fun lecture he does every year, right, Dr. Buda, or every semester?
Every semester, yes. On the last day of class, the last lecture day, I talk about aliens.
Here goes. Our galaxy is one galaxy. It has 200 billion stars. When we look out into space, we see evidence for the existence of maybe 100 billion other galaxies. If each one of those galaxies has 200 billion stars,
Intelligent life elsewhere in the universe.
When we found out about this, we couldn't wait to come down and videotape this, because normally when we're with Dr. Buda, we are in a strip pit looking for trackways.
Yes, that's my second interest. But my main interest is astronomy. That's what I do. I'm a professional astronomer. And my main research interest is galaxies. Other galaxies besides the Milky Way, the one that we live in.
Oh my.
okay, now, aliens. What would they look like? Now, you might expect that the appearance of an organism like us is going to depend somehow on its environment and its history. And the things that the appearance might relate to could be the surface gravity of the home planet. We are the way we are because we're living in a planet of a certain surface gravity that determines our weight. The spectrum of the parent star could determine what the eyes look like. Maybe the presence or absence of the moon has some effect. Maybe the composition of the atmosphere has some effect on what an alien being will look like. Or maybe other planets in their solar system might have an effect. Now, in science fiction, aliens always look humanoid. They have 2 arms, 2 legs, and maybe they don't have any hair, like this man. But we know what some of the popular aliens look like. The one in the outer limit.
But it's just your hobby, paleontology.
Yeah, I guess so. But I sure enjoy it.
Oh, you have a passion for it.
Yeah.
And we're in your office, and I just wanted you to point out some things of interest, Dr. Buda.
Well, I have here a picture of Sir William Herschel. He was a famous 18th century astronomer who discovered many nebulae in the sky. And many of those nebulae ended up being galaxies, which is why I know a lot about them. So he's kind of a hero figure to me. This is my daughter Sarah graduating from high school in 2009. That's my wife Debbie. She's on campus.
Oh, is she?
Across the street, yeah.
Oh my.
And over here, these pictures of galaxies were part of a research project involving the study of these elongated things here called bars. These pictures here are called velocity fields. This is an image of a rotating galaxy, and the color of the image in various points tells you the speed it tells you something about the speed at which material is rotating in the galaxy. And so it shows gas clouds that are rotating, and the color tells you something about the speed, their speed of rotation. And here's another galaxy which has a ring. And these are both rings, and that's my main interest, is in galactic rings.
Dr. Buda,
Yeah.
What year did you graduate?
I had my PhD oral exam on December 19th, 1983, and I received my formal PhD in May 1984.
Now, your thesis, was that your first really published work?
I was a student of Gerard de Vaucouleurs, and we had to start publishing before we finished our thesis. So it was part of my publication record, but I had already done things before that. I used to go out to McDonald Observatory in West Texas and do projects out there that got published before my PhD thesis. So,
But now your thesis.
yes. Oh, my PhD thesis is here. It's titled "The Structure and Dynamics of Ringed Galaxies." A ringed galaxy is just a galaxy which has a bright ring. It could be it could be a ring made of young stars, or it could be a ring made of old stars. But it's a ring-shaped pattern. And there are lots of galaxies that have such features, and I was interested in what the rings mean, like what causes them. And
Dr. Buda, I think that's very impressive. This is a very thick volume.
the typical PhD thesis isn't like this. It might look something more like these.
I
knew
that.
But this project, this PhD thesis, kept me very busy in 1983, to the point that I don't think I interacted with the outside world hardly at all in that year,
I can
in
believe
1983.
that. Oh, what's stuck in here?
My PhD thesis received an award.
No wonder.
It's the Outstanding Doctoral Dissertation Award in 1984. It was an honor to receive this, and it
Okay.
came with $500,
Oh,
which I gave to my parents.
oh, how
And
kind.
I also dedicate my thesis to my parents. Let me see if I can find the dedication.
Well, we have met your
There's the
mother.
dedication.
Barbara Buda is a wonderful woman.
It says,
I know they were always supportive of you.
Mm-hmm. Well, it says, to my parents, Barbara Pogachnik Buda and Daniel Adrian Buda, for their unfailing support and for surprising me that one night 17 years ago with a small white telescope that opened a door I have never closed.
That is beautiful.
It started with a little telescope.
So you never know what you're doing for a child.
Put this Yes, it was a great thing to surprise me with that telescope. That's why I'm here.
Well, the prize money in 1984,
1984. Yeah.
$500 was $500.
Mhm.
Did that make up for the time a little bit?
A little bit. I also did a master's thesis. That's what this red one is, and it's a very different subject. It's not on galaxies at all. It's called the Light Variations of Non-Radial Pulsators: Theory and Application to the Line Profile Variable 53 Persei. It was all about a variable star, and it was a variable star that was varying because its shape was changing. And that's what it was about. And I had to do a little bit of theoretical calculations, so you see things
That I don't understand.
before the idea. I would have had to type it, and it was easier for me to just write the equations by hand here.
So actually, this was before computers, really.
Yes, it was before computers. I wanted to do a thesis on stars, because I knew I was going to work with Gerard de Vaucouleurs. He was my PhD supervisor. After my PhD at Texas, I went to Australian National University in Canberra, Australia, as my first postdoc. And then after that was over, I was looking for jobs back in the United States, and Gerard phoned me and asked me if I would work on the catalog. And I was a bit reluctant, because I knew it would be a huge amount of work. But I'm glad I did it. I said yes. He needed my help. I said yes, and I learned a huge amount by doing this catalog. But it was a lot of work. I had to bring it with me, because I had to go back to Texas for my second postdoc, and we didn't finish it before I had to leave Texas, and I brought it here with me. It took another year or two to finish it, about 2 years.
Well, what an honor that he asked you to do that.
Oh, it was an honor. But a lot of the work I had done with Gerard de Vaucouleurs prepared me to work on this catalog.
Well, he knew the one to ask.
Well, I thoroughly enjoyed observing the galaxies and collecting data for this catalog. I made tons and tons of observations. He sent me out to McDonald Observatory for over 100 nights as a graduate student. Over 100 nights I went out to observe. I measured the brightnesses of dwarf galaxies. These very small, dim, hard to see galaxies, he wanted me to measure their brightnesses. It was very challenging. It was probably one of the most challenging projects I ever had to do because I could barely see these things from one of the darkest sites in the continental United States, McDonald Observatory in West Texas. It was a very, very dark site, and yet these galaxies were still hard to see with a 36-inch telescope, with large reflectors. They were still hard to see. And it was also back at a time when professional astronomers still did visual astronomy. There was a visual aspect to measuring the brightnesses of galaxies, but no one would do it that way. It's an obsolete method. What I did for this catalog is now obsolete.
Oh my.
It went the way of the dinosaurs in the 1990s.
Oh my. But you were able to put that volume on a bookshelf.
I was, yes. I know about all the parameters, and at one time collecting the data for such a catalog was really difficult. And collecting a data that was useful for astrophysics was challenging. And that's what the Vaucouleurs, you see, this is the third reference catalog. There were two others before this.
Oh.
The first and second ones. The first one was published in 1964, and it had fewer galaxies, but it had a lot less data. Data had accumulated a lot. That's why he made the second and third ones.
Okay, so this was a revision kind of thing.
Of the first one that he had published in 1964. So, but anyway, I'm glad I worked on the catalog. When I look back on it, it was an experience. But
I'm glad you survived it.
I survived it. It was a lot of work. It was challenging. It had its ups and downs.
What is this photo here?
Sulu. I got it at Dragon Con. He was a very nice man. This is George Takei. He was signing autographs, and I got an autograph of George Takei from Dragon Con. It was about 3 years ago, 2 or 3 years ago, I guess.
Let me get this on. Give them this camera too, Dr. Buda, to make sure he gets.
Kirk over there.
Oh. Wait, say that again.
I said I have Captain Kirk in the bookcase.
Oh, we'll have to take a look at that too. Got it, Larry.
Oh, there you go.
Oh.
We can get to that bookcase.
Yes. Oh, do
But
you
let
want
me,
to show? What else do you want to show?
I was going to show. This is my Galaxy Atlas in honor of my PhD thesis supervisor, Gerard de Vaucouleurs.
Oh.
That's his name. It's called the de Vaucouleurs Atlas of Galaxies.
So
And,
this is like a tribute to him, Ron.
Because in 1959 he published a classification system for galaxies that we still use. And I wanted to make it, he had never published a Galaxy Atlas, whereas Hubble, Edwin Hubble, he did the first scientifically valuable classification for galaxies. And in the 1960s, Alan Sandage, his research student, Hubble's research student, published the Hubble Atlas of Galaxies. De Vaucouleurs published his interpretation of the same thing. And I wanted to make an atlas of what his interpretation was. That's what this is. This is the de Vaucouleurs Atlas of Galaxies. The Hubble Space Telescope got a value almost halfway between both of them. Neither was right. The correct value was between their values. One fellow got, the parameter is in units of kilometers per second per megaparsec, where a megaparsec is 3 million light years. So what the Hubble constant means is it's the increase in speed of recession for every increase of distance of 3 million light years. That's what it means. De Vaucouleurs got 100 kilometers per second per megaparsec for his value. Sandage here was getting 50 kilometers per second per megaparsec. And then people who used the Hubble Space Telescope got 73, which is almost halfway between. So the actual value of the Hubble constant is 73 kilometers per second per megaparsec. So that means, and if you know that proportionality constant, you can figure out the distance to any galaxy by measuring its recession speed. The universe is expanding, and galaxies are all, for the most part, are receding from us, and that the speed with which they recede depends on their distance. And when you know the Hubble constant, you can get the distance for any galaxy once you know its recession speed. But there was something I want to say about Sandage. The Galaxy Atlas here, I wrote in honor of de Vaucouleurs, and Sandage and I had a written correspondence for a while. He died in 2010. We had a written correspondence, and he told me a few things. But I had told him about this atlas, and I sent him a copy when it was published. And then he sent me this letter. Do you want me to read it?
Yeah.
So this is from Alan Sandage. He was at the time, and I think he probably was an emeritus professor of astronomy, Caltech, and Hale Observatories in California. And I sent him a copy of the de Vaucouleurs Atlas, and even though de Vaucouleurs was his rival, he sent me this nice reply. He says, "Dear Professor Buda, please forgive this delay in acknowledging your fine and welcome gift of the de Vaucouleurs Atlas of Galaxies. I have been away from the office for 3 weeks, have returned today to find your gift. The book is, of course, a masterpiece. It will be the definitive textbook on galaxy classification for all future students as well as contemporary astronomers. You have done de Vaucouleurs proud." And then he says, "I congratulate you, Corwin, and Odoan on producing what will be the standard work on galaxy classification."
Wow.
So,
I know you were thrilled to get that letter.
thrilled to get that letter. Yes, that's one of the high points of this project. But galaxy morphology is my main interest.
Ron Buda, I just think that mask is absolutely perfect, and your students enjoyed it too.
Oh, well, good. It feels interesting to be an alien for a little while, with no hair.
Well, that is a good one, and you said that's a brand new one.
Brand new, yes. I just got it for this class, and I have a bunch of other ones. They're getting a bit old, and they dry out sometimes.
Well, that is a beauty. You look just exactly like an alien.
Yes, the mask looks the way we expect aliens to look, but that's
Right.
not what they look like at all. They could look totally different from this, totally different from what we expect.
I just wonder if we'll ever know in our lifetime.
It's hard to say. Very hard to say about that. Solid data to prove it, one way or another. We can make arguments on the basis of the number of galaxies in the universe and the number of stars, but it still doesn't really tell us what the reality is.
Well,
We can only speculate about it now.
we enjoy the TV programs talking about aliens. We are just hooked on those, and I think a lot of people are. So this was a fun thing for your students.
Mm-hmm. Yes. I think the students would be, if anything like this were actually discovered, like if the SETI project, Search for Extraterrestrial Intelligence project, actually discovered some interesting signals, people would be curious about it, perhaps more than they'd be today.
Since the first day that man stared up at the stars and saw other worlds, there has been no more haunting question than this. What will we find there? Will there be other creatures? And will they be like us? Or when that ancient dream comes true, will it turn into a nightmare? Will we find on some distant frozen planet an alien life of unimaginable horror?
Is that okay?
If I may have your attention, please. We have now come to that part of the tour which is most interesting for our student groups. You are about to enter the Cygnus 4 division, which contains no live animals. Instead, you will see recreated models of the different forms of life inhabiting our alien planets. All the animals depicted here were brought to us some 30 years ago in the early space exploratory days of the 1980s and 90s. They found our planet a hostile environment and could not survive. And now, welcome to the Sydneyan world. First, we have the Imwalk. The force of gravity on its world is 66 times greater than that of Earth. The Imwalk has the perfect structure for such pressure. On Earth, it simply went to pieces. Here we have the footleaf. It inhales methane gas through its pores, and its life fluid is in perpetual stasis. A footleaf cannot retain its physical shape in our atmosphere. Structural fatigue, we call it in metallurgy. Our next visitor from other planets is the Megazoid.
I want that costume.
It is the highest form of life ever discovered in space. It has been said the Megazoid, despite its physique, is farther along the evolution scale than man, and has demonstrably proved its superior intelligence. It communicates and has no trouble learning earthly languages. However, it is a creature with one all-consuming impulse: to kill. For this reason, the last living specimen was destroyed in the late 1980s.
This is called the galaxy beam. It's about an encounter with an intelligent, benevolent alien. Let's go to the beginning, or near the beginning. So where's the? Are you able to hear? No. So a man owns a radio station, but he's using his station for research, not to broadcast commercial TV. His wife is confronting him about it. Autographed picture of William Shatner at Dragon Con a few about.
And he autographed that.
Yeah.
Can we pull that out,
yeah,
Dr.
yeah,
Budick?
move
Careful with the...
This can go here. And pull this out. He didn't say anything. He just signed.
Just signed his name, but
anyway, I still.
He knew he knew you were in the field, didn't he?
Perhaps. I mean, I still enjoyed meeting him, even though we didn't have a conversation at all.
Oh, absolutely.
But it was interesting.
It's a fun thing for everybody.
Here's a sketch. It's an unfinished sketch. In 1981, I had telescope time at Cerro Tololo Inter-American Observatory to collect data for my PhD thesis. And I had taken photographic plates of galaxies for my thesis, and I needed a certain type of measurements to calibrate those plates so I could use them for astrophysical studies. And I was assigned time on the 36-inch telescope at Cerro Tololo Observatory in Chile to collect the data I needed to calibrate my plates. But you can only collect that kind of data if the sky is perfectly clear. And on my first night, I was dodging clouds. I couldn't observe. So I didn't have anything to do while I was waiting. I just made this sketch of this giant nebula that in what's called the Large Magellanic Cloud. It's called 30 Doradus. It's one of the biggest nebulae in the sky. But it's viewed from a distance of 150,000 light years in the Large Magellanic Cloud. And I made this pencil sketch of the nebula. It's called the Great Looped Nebula. And you can see how it gets its name from these loops, the ribbons. Oh. It's called the Great Looped Nebula. And the nebula was centered on a star cluster, which you can see right there. Now, I had never seen this nebula before.
Now, again, you said you were in Chile?
Yes. It's visible from the southern hemisphere, but it wasn't visible from Texas. It's not.
And where in Chile? Where
I was
in relation to Santiago?
I was 260 miles north of Santiago, near La Serena. It was about the latitude was about 30 degrees south, as opposed to in Texas, McDonald Observatory, which is 30 degrees north. But from 30 degrees north, you cannot see that nebula at all. It doesn't rise above the horizon. So when I went to Chile, that was the first time I ever saw it. And I'm still amazed at what I saw, this beautiful nebula. I was clouded out, so this is like an unfinished portrait of Washington. I never finished it. I never had a chance. Oh, but that's what that is. That's a pencil
Now,
sketch.
would you have to go back to Chile, do you think, to
Well,
continue that? Or you have photos? You have
I
photos?
wouldn't be able to continue that because it's because the method is an obsolete. The collecting of to calibrate the plates. Nobody uses plates anymore. I mean, I have photographic plates. They're down there. Those are antiques, and here's a drawing of the Orion Nebula that I made at McDonald Observatory. Again, under similar conditions when I couldn't really collect data. I just dodged clouds, and I made this sketch of the Orion Nebula with the McDonald 30-inch telescope, and it was stunning to see it. So, only the nebula is caused to glow by that one star in that little group in the middle there. This one star is hot enough to cause the nebula to glow. So this is the Orion Nebula. Up here, we can put this here. That's Comet Hale-Bopp. And I have a sketch at home that my older daughter, Sarah, made when she was about 6 years old. She came out with me and Debbie, and when I made my sketch of this comet as seen with binoculars. And I only wish I had her sketches, because you'd rather see hers, because hers are so amazing. She was only 6 years old and she drew the comet.
No way.
She did, and it's kind of a prize to see what she did when she was 6.
The specimens you have here, Dr. Buda?
A lot of these I got at the Tannehill Rock Show, or at various museums. It's the Tannehill Rock and Gem and Mineral Show. Yeah. I bought some of these.
Dr. Ron Buda, we thank you again for your time, and we knew this was going to be a fun thing and couldn't wait to photograph that, because normally we are